Hello. For this warm-up, we're going to be working on solving absolute value equations and compound inequalities. So as with the other warm-ups, go ahead and try all of the problems first, like you're taking your final, and then come back here and kind of go through each one and mark it up and see how it went for you. So for numbers 1 and 2, when you have an absolute value equation, you're going to first get the absolute value alone. When the absolute value is alone, you're going to set up two equations. So whatever the absolute value is, you're going to just take away the absolute values and you're going to set up x equals whatever h is. For your other equation, what you're going to do is you're going to take whatever x equals and you're going to negate whatever it equals. So you're going to solve the positive one and the negative one, and you're going to solve each of those equations. Once you are done with that, you are going to check your answers for two reasons. You're going to see if it works in the first place, so if you get a solution, but then also you're going to see if you did it right. If you plug it in, it should work. So let's take a look at this first one. First step, get the absolute value alone. Well, it is already, so that's good. We are now going to do step 2, set up two equations. So whatever the absolute value is, you're not going to change that at all. So this is going to stay x plus 6. And if it was negative, like x minus 6, it would stay x minus 6. What does change, though, is whatever it equals. So whatever it equals, you're going to write one positive and one negative. Then step 3 says solve each equation. So now that we have these two equations, we're going to go ahead and subtract 6 for both of them. And we're going to get x equals -4 and x equals -8. We're going to check our answers by plugging them back in. When we do that, we have the absolute value of -4 plus 6 equals 2. And that ends up being true. The absolute value of 2 is 2. When we plug in -8, we get the absolute value of -2 is 2, which is also true. So we write our answer then in set notation. Generally, we write it from least to greatest here. So our final answer here is the set of -8 and -4, because both of those work when you plug them back in. For number 2, we cannot do step 2 yet until step 1 is done. So we have to get the absolute value alone. Please don't look at this and write equals 19 and -19. We have to get the absolute value alone first. So we are going to move the -1 to the other side. And then we're also going to divide both sides by -4. And when we get the absolute value of 2x minus 5 equals 5, this is where we can then split this up into two equations. So whatever's inside the absolute value is going to stay the same. So it's going to be 2x minus 5. It's whatever it equals, that's one is going to be positive and one is going to be negative. So we've done step 2 here. Now we're going to go ahead and we're going to solve each of these equations by getting x by itself. And for this other one, when we do this, we get a weird answer here. -5 plus 5 equals 0, and that's okay. We can do 0 divided by 2. We would end up getting 0 as our answer. So right now we have x equals 5 and x equals 0. We're going to do a quick check by plugging these back in. So 2 times 5 minus 5, 10 minus 5 is 5. So we're trying to see if this actually gives us a true statement when we plug this in. So absolute value of 5 is 5. So this becomes -20 plus 1 equals -19. That is absolutely true. So now we're going to test 0 by plugging 0 in. So 2 times 0 minus 5. That ends up becoming -5. When we take the absolute value of -5 and multiply that by -4, we end up with a -20. So we once again get a true statement. So both of those values end up working. So our solution set for this one is 0 and 5. So now what we're going to do is we're going to solve some compound inequalities and then also do some compound absolute value inequalities. So when you have these inequalities, you are going to get x by itself. So we're going to go ahead and we're going to move the 8 to the other side. Oops, that should be a 1. We're going to divide by a -1, and here you should have some warning signs going off in your head saying, okay, if you multiply or divide by a negative, you have to flip your sign, which means, I wrote it as sign, which means this is going to end up becoming x is less than -1. Then we're going to go ahead and solve our other equation at the same time. We get 5x is less than 25, so therefore x is less than 5. So you're going to solve both of these and you're going to graph them. X is less than -1 would have an open circle at -1 and be everything to the left. X is less than -5 would have a open circle at 5 and be everything to the left. To identify your answer, you have to identify what type of problem this is. This is an OR problem. So OR problems mean anything in either one that is shaded should be part of your answer. And problems would be the overlap. But ORs is anything that's shaded should be your answer. So over here at -5, I see something above it shaded, so it's part of my overall answer. At -1, while it doesn't work in one, it works in the other one, so it still works. So does everything all the way up to 5, but not including 5. So now when we write set and interval notation, it's only based off our final answer here, our final graph. So set notation is your squiggle, whatever variable you use, such that, and then you only write about the answer here. So everything less than 5 ended up being my final answer. Interval notation is from left to right. So all the way on the left of the graph is -infinity, and that is shaded. And the farthest right that's shaded is 5, and it's an open circle, which makes it a parentheses. So number 4 here is the exact same problem. So this problem right here gave me an answer of x is less than -1. This other one here gave me an answer of x is less than 5. So I'm going to jump right to going ahead and graphing those ones because I've already done the solving of them. What's different about this one is this one has the word and. So if you're looking at this, if you see the word and, you are looking for the overlap. So on your graph, the only part that's going to be your final answer is where you see both of those lines shaded. So over here, all the way on the left, I see both red and black above that. So that's part of my final answer because it works in both of them. At -1, though, we make the switch and it doesn't work in both of them. So that's where our solution stops. Then, when we write our answer inside an interval notation, you are only looking at your final answer on your graph. So for your set notation for this one, it is squiggle x such that, and only everything less than -1 works. For interval notation, all the way on the left is -infinity, but here we stop at -1. So we're once again going to use an open circle or a parentheses because of the open circle. So let's see how this applies then to absolute value graphs. So the process is going to be the same. Get the absolute value alone first. So for instance, this one we have to divide by -3. But all of our rules for solving inequalities still stay the same. So you have to switch your sign when you are dividing by a negative, which means this becomes the absolute value of x is greater than 8/3. Once the absolute value is alone, we are still going to break this up into two different inequalities. So what is on the left-hand side, or whatever is inside the absolute value, is still going to stay the same. And whatever it equals, the 8/3, you're still going to have one where it stays the same and one where you make it negative. And in your first inequality, nothing changes. So your first one, you just basically get rid of your absolute value. So x is greater than 8/3. In your other one, where you made it negative, so here, right here, you made it negative, you also have to switch your sign. So when setting up your second equation or inequality, you want to negate it and switch your sign. Additionally, you also have to pay attention to what word would go in between here. So if it's a less than or less than or equal to, we think of less than, and you would write the word and in between. If you have greater than or equal to, we think of greater. So this one here is a greater than, which makes this an or problem. Then you would solve these inequalities. They are already solved for us, so we can just go ahead and plop them on our number line. So we can't just graph it as going out or going in. You have to pay attention to which direction it's going. So pay close attention for this first one. X is bigger than 8/3 means that at 8/3 we want everything more than that, which is why we're shading to the right. The next one, x is less than negative 8/3. So at negative 8/3 we have an open circle and we want everything less than that, which is why it's going out in that direction. So you graph your inequalities, and now we think of what our final answer should be based off of it being an OR problem. OR problems are anything that's shaded on our graph should be part of our final solution, and anything that's not shaded anywhere isn't part of our final solution. Which means this is going to be what we write about in set and interval notation. So we're going to do our set bracket, x such that if there are two parts here, you have to write it as two parts in your answer. So x is less than negative 8/3, or, and you can write the big union symbol or the word or, x is bigger than 8/3. Same thing with interval notation. You see two separate intervals, which means you have to write both intervals. So left is negative infinity, right is positive infinity. So everywhere that's shaded on the left starts with negative infinity, and it stops at negative 8/3, but then it picks up again at positive 8/3 and everything to the right. So we're using that U symbol for union, also known as the word or. So let's go ahead and try another one of these. So we're going to go ahead and get the absolute value alone first by subtracting 4 from both sides. We get the absolute value of x plus 1 is less than or equal to 5. Here's where we split it up into two different inequalities. We write x plus 1 is less than or equal to 5, so we leave that one alone. We're going to leave alone x plus 1. We're going to negate the 5, and we're going to switch our sign. Once we've done both of those, we can also then write what word is going to go in between here. So since this is a less than, this ends up being an and problem. Now we can take each of these equations and solve them. So we are looking for where x is less than or equal to 4 and where x is greater than or equal to negative 6. So we're going to go ahead and graph each of these inequalities and then look at where our overall solution would be. So x is less than or equal to 4 would be a filled-in circle at 4 and everything to the left. X is greater than or equal to negative 6 would be a filled-in circle at negative 6 and everything to the right. Because this is an and problem, you're looking for the overlap. So the part in the middle here you can see is shaded for both of those. And that's why this middle section here ends up being our solution. Our endpoints for this one are filled in because our points on our graph above are filled in. So we're going to write about this solution in set and interval notation. So we're going to open it up with x such that, and then there's one chunk here, which means we're going to put those together in one interval. We want everything in between negative 6 and 4, which is why it's negative 6 is less than or equal to x, which is less than or equal to 4. In interval notation, from left to right, it's negative 6 to positive 4 and everything in between there. So thank you very much for listening. Let me know if you do have any questions on anything.